All right. Thank you for joining me. You guys hear me okay? So my name is Andy Watts. I'm a senior cloud architect with AWS Professional Services here in Singapore. And my day job is advising customers on how to run AI projects. So the topic of my talk today is artificial intelligence to delight your customers. So let's get started. So as you will have gathered today, long history of AI at Amazon. From the earliest days of Amazon.com, we knew we had an opportunity to deliver great personalized, targeted recommendations. And so like most people, we started off with collaborative filtering. And as the product catalog grew, we knew we needed something more, and so we started looking at factorization machines. And it's a challenge today. As the product catalog grows, we continue to work on our recommendations engine. But also, as the number of products grew, we had to invest in AI and machine learning for inventory management and fulfillment automation. We did a lot of work here with computer vision, robotics, routing of robots through those fulfillment centers. And as a continuation of that fulfillment automation story, we launched a project called Amazon Prime Air, which is our drone delivery service. The goal here is to help that last few miles of the delivery and get customers their packages as soon as possible. Now, of course, drones are very challenging, so we had to do a lot of work on, again, computer vision, but also routing, navigation, and, of course, collision avoidance. Amazon Alexa, I think, is probably very well known. It's a general-purpose AI, most commonly found inside our Amazon Echo devices. And you can ask Alexa any number of things now. You can ask it to read you the news, play your music, convert weights and measures. And between Amazon and the community adding skills all the time, the richness of your interactions with Alexa is quite impressive today. And most recently, Amazon Go. This is our, ironically, physical store in Seattle, Washington, where you can go in, take an object from the shelf, and then walk out without having to queue and wait for a cashier. We achieve this through a system of IoT and sensors on the shelves and computer vision in the roof. And it's quite sophisticated. It can detect now when you take a device, a product off the shelf and you put it in your basket. If you take it from the basket, put it in your bag, and then if you take it from your bag and put it back on the shelf, all of this is going to be tracked. It's pretty impressive technology. So as a consequence of running programs like this, we've gained a lot of experience in what goes into an AI project. And as of today, we have several thousand machine learning engineers and data scientists working on different AI problems across Amazon. But the problem I want to talk about today is the one I get asked about the most, and that is customer facial recognition. Pretty much every industry that has a customer-facing real-world presence is looking at customer facial recognition. We've had requests from banking, from petrol gas service stations, from airlines, even law enforcement, probably more criminal facial recognition for law enforcement. But to get a better understanding about what we mean when we say facial recognition, I have a short video here, so let's take a look. Okay, so there's a lot going on in this video. First of all, we've got high definition or 4K video at 30 frames a second. And across each of those frames, we're looking to first detect the presence of faces, and then we're looking to do recognition, which is take that detected face and look up against a database of known faces. And then almost certainly, we're going to want to take some action once we've detected a known person. So how would we go about architecting something like this? Well, we come back to the Amazon AI stack. And anytime we're architecting a solution, we always like to start with our highest level application services. These are services that are as close to plug-and-play turnkey as we can make them. Each of these services you see on the top tier comes with a robust web console with demos, so you can get in there and evaluate it and see if it fits your needs. If it does look good for your project, then each of these services has a robust API and the SDKs, so any integration work you end up doing is, again, as straightforward as it can be. I won't go in depth in each of these. I think my colleague Steve covered these earlier. But if we come back to our problem of customer facial recognition, then Amazon Rekognition, our image and video recognition service, is the obvious place to start. So there's one feature in Amazon Rekognition that is particularly helpful here, and that is facial collection. And so this allows you to bring a collection of your customer faces to the recognition service, such that later on, when you submit images and video, it can look for those faces, those known faces. It's important to note that we recommend that your customers opt into this program. We're still all learning how customers and consumers are going to respond to this. But once they've opted in and you upload the faces as a face collection to Rekognition, we're storing those as a vectorized representation of the face, not the actual images. So moving on to architecture, you can see in the upper right here we have the face collection that you've set up in Amazon Rekognition, and in the upper left we have our camera in the store. And I think, like most of you, we like to decouple our services with queues and streams, and so you'll see here I'm using Kinesis video streams. We like streams a lot because they allow us to have many producers putting content into a stream and then many consumers acting on that stream. In this case, we just have one camera that's pushing a video feed into Amazon Kinesis video streams. We have one consumer, and that is Amazon Video Rekognition, and it's going to pick up that video and try and identify faces from our collection in that video stream. In the event that it finds a face, it's going to drop that recognition into a second stream. You can see that in the lower part here. And then we're going to have a script that we've deployed on AWS Lambda run some action based on this recognition. A typical use case here would be we've recognized a customer as they've entered. Let's look up their purchase history. Let's go to a recommendation engine and get some products we might recommend to them. Let's package that up, send it to our customer-facing staff in the store, and enable them to go and meet the customer and provide a better experience. A couple of things about this architecture. So it's all managed services, so it's all on demand. It will take you a couple of minutes to provision and get this up and running. It's utility pricing, so it's going to be low cost to run a proof of concept and see if it works for you. And then it's serverless as well, so there's no service to patch or security patches to apply or passwords to change. Even the script that we've written to go and pull this purchase history and pull these recommendations, we've deployed that script on Lambda. And so it's auto-scaling, it's going to be always available, it's going to be high performance. And so it's a great place to start. But there are times where our turnkey application services aren't going to fit your use case. Something industry specific. Maybe you want to build and train an AI to deploy at the edge. Maybe you're looking to do vehicle recognition or apparel recognition. Whatever your use case is, and there are many, there are times where you're going to want to build your own AI. And so that's where we get to the interesting stuff of the AI platform services, and specifically Amazon SageMaker and AWS DeepLens. And so I'm going to get into how these tools will help us with building an AI, but I'm conscious that for many people here, an AI is a bit of a black box. It's going to be a mystery as to what's going on inside of an AI. So I want to take a couple minutes just to give you a brief overview, try and give you some intuition as to what goes on in an AI, so that as we talk about building and training, it'll make a little more sense. Okay. So most of the advances that you see in the last few years around voice recognition, image recognition, all these amazing artificial intelligence technologies have come about because of the idea of deep learning. And deep learning says that we can have a stack of neural networks, whereas previously you might have just had one or two. These days you'll have many, many, many. And you can think of these layers in this stack as layers of abstraction. And so in this diagram, you can see that we're feeding photos into the input layer. We would translate these photos into a vector of numbers, and so the input layer would have many more nodes than we're showing here. That would take that photo, and it would pass all the data about that photo to the first hidden layer. And it's these hidden layers where the magic happens. We can think of that first hidden layer as learning to recognize edges inside that photo, small features within the image. And it passes all of its values onto the second layer, which is going to learn how these small edges combine to make facial features like noses and eyes and mouth. And then that third hidden layer is going to learn how to combine these features into faces. And so it's these hidden layers that are really, really fantastic for us here. And you can see this model of abstraction follows through to voice recognition as well. If we think about Alexa, its input is a stream of noise. It knows nothing about it. And so the first hidden layer might learn to recognize phonemes, individual vowel sounds or consonants in that stream of noise. A third hidden layer might learn to recognize words from those phonemes, and then sentences and phrases. And as you add more and more layers, you can look to extract semantics and meaning from what starts off as just a stream of noise. So there's a lot going on here. There's one more thing I want to mention. Each of these nodes that you see in these hidden layers, each of these nodes is taking values from all the nodes in the previous layer, and it applies a weight and a bias and an activation function before passing a value on to the next layer. And it's these weights and biases that when they're just right, the model is able to recognize faces or cats or dogs or whatever it is. And so the challenge we have is arriving at the correct weights and biases for each of these nodes inside the neural network. And that's where training comes in. So what we do is we pick random numbers for these weights and biases, and we put a photo through, an image through, and we look at the result. And then we do the same again with a second set of random weights and biases. And based on those first two, we can see which direction we should go in the weights and biases, which one is more promising. And so we'll continue to tweak, and this happens automatically, we continue to tweak the weights and biases and inside these nodes such that the model as a whole is performing better and better over time. And this is and so once the training is complete, the model is good to go, and you can get predictions out of that model. The training phase is computationally very heavy. You will have heard about the need to use graphical processing units, GPUs, in order to crunch all these numbers and do this matrix math. Once the training is complete, however, and we've arrived at the optimum values for each of these nodes, we can use that model to get predictions without needing a lot of compute. And so deploying a model to an edge location or to a small device and using it for inference and predictions at the edge becomes quite possible. So having done a lot of AI projects in Amazon, we've learned a lot of things and come across a lot of the challenges. And so I want to talk about those challenges right now. The first challenge we encounter is collecting and preparing sufficient data. Anytime we consult to a customer on an AI project, almost any time, we would include a data engineer, because this is a significant piece of work that needs to happen at the beginning of a project. We need to first make sure we've got all the data in the right place, we've got it in the right format, validate it somewhat, and we'll likely need to do some feature engineering with that data to help prepare it for the data scientist. Once we've collected and prepared the data, it's the job of the data scientist to come in and start thinking about which algorithms and which settings to use for those algorithms. And this is a tough job. This is, there's no magic solution here. The data scientist has to try several different algorithms, many different settings, and it's a challenging part of the process. The data scientist is going to have some algorithms that he wants to try, and he's going to want to run the training for those scenarios. And so he then needs to somehow set up and manage a training environment. Now, most guys, they start with their local notebook or one or two servers in the office. But it's important that we enable these data scientists with more resources so that they can run more training, try different scenarios, because the more iterations that our data scientists can get through, the more likely we are to get a model that meets our requirements. Then we need to train and tune the model again. So having been through these first three phases, we'll have an idea about what algorithm we want to use for our AI, what settings might work, but then we really want to optimize those settings. And so that's what this phase here is. And then we're going to need to deploy it. And our data scientist, he's not an infrastructure engineer or a DevOps engineer, so he's going to struggle to work out where should he deploy this model to. How can he deploy it such that it's highly available? How can he deploy updates? How can he do scaling? And so that's the last challenge we find, the scaling and managing of a production environment. So over the years, we built a number of different tools internally to try and help with this workflow. And then a few years ago, we looked to take all that learning and put it together in a single tool and make it available for our AWS customers. And that is Amazon SageMaker. So let's talk about how Amazon SageMaker helps with the problems I just discussed. So I'm not going to talk more about the data engineering piece that comes first, because a lot of that is covered in our big data and analytics workshops. And I'm going to start with the designing and build phase of an AI. So most data scientists are working inside something called a Jupyter Notebook. This is a web-based Python programming environment. They can write code, it gets run, and they get the output back in their browser. It's a really productive, fast-paced development environment. But it requires that you get it set up an environment with appropriate libraries and packages installed. And so the first thing we did with SageMaker was provide a pre-built, hosted Jupyter Notebook service. In addition to hosting the notebooks, we also provide a lot of optimized algorithms. So there are probably 8 or 9 common algorithms you use for most problems. And so we've built our own versions of these algorithms, and we've engineered them to perform better across highly distributed training. And so that's also included in the build phase. And lastly, these notebooks come with everything you might need. They come with TensorFlow, MXNet, high-level libraries like Keras or Gluon, CNTK, Caffe2, whatever you might need is all there. So let's take a look. So this is the AWS console, ever-growing list of services. The machine learning services are all grouped down here together. I use SageMaker a lot, so it's in my recently used services. If we click through, all right, we've got a big button there, create notebook instance. So we're going to create a notebook. We'll give it a name. We're going to choose an instance type. I'm going to choose T2 because it's the cheapest. I'm not planning on doing training on this notebook server, so T2 should be fine. My other options there are M4 if I think I need a little more memory, or P2 and P3, which are second and third generation of GPU optimized instances. Okay, so I've named my notebook, I've chosen the instance type, and I've clicked create. So you can see it there, it's in the pending state. It's going to take about a minute to build, so we'll skip forward. Once it's built, you'll get a link which will take you to your notebook, and if you've worked in notebooks before, this will look familiar. Let's see. Okay, a couple of things about these notebooks. They come with a great collection of sample notebooks, and it comes with all the kernels that you think you might need. So it comes with TensorFlow, MXNet, Python 2, Python 3 versions, Spark, PySpark. Also comes with a terminal should you need to get on there and install new packages or check in, check out to your GitHub. The sample notebooks are great. We break them up in terms of algorithms and use case. But for algorithms, we'll have ones for factorization and anomaly detection, and then for use case, we might have recommendation or image classification. And for each of these notebooks, they're very well documented. They go into depth about the scientific aspects of the algorithm and how you might need to tweak them. And here I'm just showing how you can get a terminal on your notebook. So this is great. Previously, your data scientist would perhaps have to struggle a little bit to get a notebook up and running with everything he needs. Right now, you can get one in a minute or two. And of course, it's utility pricing. So when you not use it, you can hit stop and you won't be charged. I mentioned the algorithms. What we've learned is that most problems that we encounter fall into one of these categories on the left. You know, if we're trying to do forecast sales, it's a time series prediction problem. If we're looking to categorize books, it's a discrete classification problem. And so depending on the problem that we're tackling, we have go-to algorithms, and that's what you can see on the right here. Now, in most cases, we'll probably try a couple, maybe 3 algorithms, but there's one go-to algorithm that you start with, and that's what we're showing here. As I mentioned, these are Amazon implementations of these algorithms designed to work better across distributed training. But for the most part, there are implementations of algorithms in the public domain. I think DeepAR is the one original work in there. Okay, so that's the build phase and how we try and help the build phase with Amazon SageMaker. I want to talk about the training now. So specifically, I want to talk about the virtues of distributed training and the challenge of hyperparameter optimization. So this is a screenshot from a Jupyter notebook. And what you can see in the upper code block is that I'm creating a TensorFlow training job. And I'm saying that for this training job, I want to use the C4X large instance, and I want 2 of them. And so right here within my Python code, I'm able to define a training job. And when I call that fit method, it's going to go off in the background and scaffold those 2 instances, stream the data that they need, and do the training distributed across them. And so if you don't need to leave your notebook for that. And since we have this screenshot, in the lower code block, you can see that you can also call the deploy method and again specify instances and instance type and deploy your model into production from within your notebook. If you run a training job, you'll see it back in the console, and you can see the log output, and you can see how the machines are performing. But what we found is that there are some people who don't know Python, and they don't want to learn Python, but they would still like to run some training jobs. And so that's what I'm going to show you here. So within the console, within the job section, I can create a new training job. I'm going to give it a name. Let's call it My Sales Predictor. And the first thing it's going to ask you to do is choose which algorithm you want to use. And so I'm trying to do a time series prediction, so I'm going to use DeepAR. I then need to choose what instance types I'm going to use and how many of them for the training. I'm going to use the latest generation of GPU instances, P3 2x large, and I'm going to use 4 of them. I want my training to complete quickly so I can get back to iterating. If I'm worried about my training running out of control, I can put a maximum runtime there. And now, depending on the algorithm I've chosen, I'm going to have different hyperparameters. So I'm doing time series forecasting. And so 2 of the most important hyperparameters with time series forecasting are how far back are we going to look and how far forward are we going to predict. And so that's context length and prediction length here. I'm looking back 1 year to predict 30 intervals into the future. So normally you would do this in Python, but it's not always necessary. I then need to set up the data that we're going to use for this training job. And so most people these days have their data lakes on S3. And so we're going to have our data on S3. The data can be in JSON format or Parquet. Of course, we have tools to help you change that data if you need to. So that's the training data I've defined there. We can also define test data. And if you define a test set of data, what each of these algorithms do is they train first on the training set of data, and then when the model training is completed, it will also run that model over the test data. And give in the output, you'll be able to see how the model performed against the test and how it performed against the training. And the goal is that the model performs great on the test data that it's never seen before. So training is a big job, requires a lot of compute, and so if possible, we would recommend the P3, the latest generation P3 instances. These instances have the latest NVIDIA Tesla V100 GPUs. They offer 1 petaflop of compute performance. They have high bandwidth connection between GPUs and to the GPUs. So they're pretty much the best matrix math factorization compute devices that are available today. Okay, I want to talk a little bit more about the idea of distributing training because we think it's a big deal. Data scientists' time is precious, and we don't want them sitting around waiting for their training jobs to finish. And also, the success of any AI project typically depends on how many iterations our data scientists can get through. And so the biggest way you can enable your data scientists is by giving them the ability to distribute their training jobs wide and get the results quickly. The idea that a training job might take 10 hours on one machine, therefore if I distribute it across 10 machines, it should only take 1 hour. It's not quite linear, but it's not far off. The other thing to consider is that adding more devices and distributing the training is going to increase the cost, but that saving in time is significant. And again, the relationship is not linear. So adding a little bit of cost to distribute your training will save you a lot of time. And again, time is important for your data scientists. Okay, the big one, hyperparameter optimization. So at some point in the project, you've got a model that you're somewhat happy with, but you want to really make it the best it can be. And so you're going to have to do a lot of tweaking, a lot of optimization. And this is a very time-consuming process for our data scientists. And so we look to automate this with hyperparameter optimization. And the way this works is you can think of it as an AI that is training your AI. It sounds terrifying, but it's not that bad. The AI that's doing the hyperparameter optimization is going to select random hyperparameters for your model, run a training, and then it's going to tweak those hyperparameters with the goal of either improving the accuracy, the precision, the F1, the training, the recall, whatever you define. It's going to run many, many trainings in parallel and sequentially to arrive at the best hyperparameters for your model. So you can think of it as running regression over your hyperparameters. So again, this is It's a big time saver for your data scientists, and it can often have a big impact on the performance of your model. Okay, so that's the training phase. I want to talk about the deploy phase. So this is again been a challenge for our data scientists. They want to deploy their services into production. They don't want to have to hunt down a DevOps engineer. How can they do this? And so we've put some effort into putting these tools in the hands of our data scientists. So what you can see here is the SageMaker console. I've got two models trained, Model A and Model B, and I'm gonna deploy Model A into production. So we have the concept of endpoints and endpoint configurations. Endpoints are what your clients are going to talk to. There's going to be a fully qualified domain name. You're not going to want to change your endpoints. But you can change the endpoint configuration if you're looking to do blue-green deployments and the like. So here I am creating the endpoint and the endpoint configuration in one wizard. So at the start, it just had a single model behind this endpoint with a single instance. But I'm going to add the Model B because I'm looking to do some A/B testing. I've got a new version of my model. And I'm going to change the weighting. I want, let's say I want 3 to 1. I want the traffic to go to Model A in 3 to 1. So I can update that all in the console here. And so I'm specifying the instance count here, but there is the option to enable auto-scaling. All right, and there it is. That's going to deploy. If it's already deployed, it's going to update the configuration. And so just like that, you've deployed 2 models into production, low balance, weighted load balancing, and you can go forward from there. Okay, before we leave the AI platform portion of the talk, I want to talk about AWS DeepLens. This is a deep learning enabled camera. It's high definition, does 4K and 1080p, and it allows you to deploy your AI models to the camera and run inference on the edge, on the images, as the camera is pulling them in. It comes with a great set of sample projects to get you going, and integrates with SageMaker, so you can deploy from SageMaker very easily. Also integrates for Lambda, so that action that you want to take, if the recognition happens, can be done by Lambda. So it comes with a few sample projects. You can see here we have face detection, we have activity recognition, object detection, cat, dog recognition, very important use case. We have artistic style transfer. This is where the camera applies an artist's style to the video as it comes in, and make your video look like a Monet or a Picasso. So these are the packages that we built when we launched it, but as you'd imagine, there's many, many new projects popping up on GitHub and from the community. Okay, before we leave the Amazon AI stack, I want to talk about the deep learning AMI at the bottom here. AMI is an Amazon machine image, and so if you're looking to build your own development environment, your own training environment, and you want a machine image that has everything installed, ready to go, then this is a great start. You can clone this image, customize it how you want, and then go forward and launch further instances with that image. And it has everything you might need on there from, again, TensorFlow and MXNet and the high-level languages like Gluon and Keras. I want to give you an idea of some resources. So professional services here in Singapore. We do a number of things in the AI space. We do discovery workshops with business execs and owners of lines of business. This is really an ideation, a brainstorming phase where we work backwards from the customer and see how AI can help. We do hands-on boot camps for more your engineers and your data science audience. This is where we deep dive some of the algorithms, some of the solutions, and we implement them together. And then we do delivery. We have a team of data scientists with expertise in different domains. And so we're working with customers to deliver, segmentation projects, recommendation projects, targeted marketing. And so we can certainly help you with model development if you don't have those skills in-house. The AWS Partner Network is always a good resource. We have a number of boutique AI partners with deep expertise in different areas. And then we have the larger global system integrators that often have very large benches of data scientists themselves. I know recently we did a project with Deloitte to do automated vehicle damage assessment. We built a system of AIs that would assess what parts of a car were damaged and how much that would cost to replace. So by all means, reach out to our partner team if you're looking for assistance on an AI project. And lastly, we have our Global AI Solutions Lab. This is where we bring together AI and machine learning experts from across Amazon, from Amazon.com and the fulfillment business to Amazon Studios and the game business, and of course AWS. A lot of expertise, a lot of experience, and we're able to bring them together to do workshops with customers. Okay, I think that's all I have for you today. So I'd like to thank you very much for your time, and by all means reach out. Thank you.